This video is intended to review you on how to write chemical formula, which is needed in our lesson writing chemical equation. So I hope that at the end of the video, you can identify the charge of the ions and then write a chemical formula using the crisscross method. There are some vocabulary terms that I would like you to be refreshed. These was from your lesson last year when you were in grade 9. One is monoatomic ion. It's a single ion with a charge, calcium +2 and chlorine -1. So our goal is how do we identify the charge of the ion? Then another, when we say binary compound, it is made of two different elements bonded together, and usually it ends with IDE when you name them. So example, sodium chloride, potassium iodide, or let's have magnesium sulfide. So it ends with IDE. For our lesson in chemical equation, you need to give the correct formula or check the equation if it has the correct formula. By doing so, it would be easy for you to balance the equation. Now, let's move on to identifying the charges. Okay, I will not dwell on why these elements need to form ions. Okay, but well, basically because you've learned that in order to become stable to achieve full valence. Now, for the charges of the monoatomic ions, I want you to use this table as your reference. You may use the periodic table if you have a periodic table of elements, you may use that. But you might get confused with the oxidation charges or oxidation states, or shall I say, the charges that are present there. Let's go to ion. If you have a periodic table, go to ion. Check. There are so many charges there. So which one to be used? Now, what you're seeing on the screen are the most commonly used charges. We will be using this, okay? So that you will be guided, we will use this one. And of course, because it's what I've said, commonly used for common chemical substance. Now, if the element is found in group 1, hydrogen, lithium, sodium, potassium, okay, and the rest, it means that the elements here have +1 charge. Make use of +1. So we have here beryllium, magnesium, we have calcium, and so forth. The elements here, okay, if they will form into an ion, it will achieve +2 charge. Positive, negative. Why positive, negative? It's not about the integers in math. It indicates here that positive means there are more protons in the atomic nucleus, okay, compared to electrons. Negative here means there are more electrons, okay, than the protons. That's what we meant by the positive and negative. Now, so if I say give the ionic charge of nitrogen. Nitrogen is found in group 5. Therefore, it has -3. Okay. Give the ionic charge of aluminum. Aluminum is here. Oops. I'll make use of the yellow. Aluminum is here. Therefore, the charge of aluminum is +3. Okay. We have fluorine, chlorine, bromine, iodine. The charge, okay, that will be used for each of the element is -1. Okay? Now, these are, I'll mark check, these are our representative elements, group A elements. In your periodic table, okay, it's group, there are periodic table that uses group A numbering. So group 1A, this is group 1A, 2A, 3A, 4A, 5A, 6A, 7A. Okay? Now, please try to take a look at group 4. Group 4 is a very unique group because we have there the carbon. It has tendencies of giving up or receiving electrons. Okay? So that's for group 4. Now, what about here? What do we call these groups of elements? We call this group B elements or transition elements. Okay? Here, the metals here have 2 or more charges. If we have iron, look, try to take a look at iron. Iron here has +2 and +3. Okay? So it will indicate also a different substance if the subscript is changed. But of course, they belong to one family. They have similar properties. Now, aside from that, okay, so in our transition metals, okay, how do we know in a chemical equation if it's a transition metal? It's usually using the stock system. The word, the chemical name is using the stock system. When we say stock system, it has the name of the element and then a Roman numeral that indicates the charge. Okay, so iron 2 means +2 charge is used here. So we have iron 3, +3 charge is being used. So if we have iron 3 chloride, example only, therefore +3 is used in this compound. The charge that is being used is +3. Okay? So we make use of Roman numeral. That's a stock system. Now, there are 2 elements exempted to the Roman numeral, to the stock system, which means to say we do not put Roman numeral for silver and zinc. It is because silver is +1, it has only 1 charge, and zinc also has only 1 charge, and that's +2. Do not write Roman numeral for these 2 elements. Okay? Then next, we have polyatomic ions. These are ions that contain 2 or more non-metal elements, are groups of non-metal atoms that carry a charge. Example is sulfate, SO4. Sulfur is a non-metal, oxygen is a non-metal, and they have only 1 charge. They're considered as 1 atom, but made up of 2 or more. We consider it as 1 atom, and it has a -2 charge. Okay, so that's polyatomic ion. Now, in writing the formula in a chemical equation, I want you to make use of this table as your guide. I will allow you to use this during the test or during the quarterly exam. Okay, so I hope you can now identify the charges of elements of monoatomic ions. Now let's do the formula writing because we use the charges in writing the formula. Okay? So the goal is to make the compound neutral, which means to say there should be no charge. To do that, compounds follow, the formation of compounds is based rather from the law of definite proportion. There is an exact ratio of the number of elements present in a compound for it to be formed. So when we say aluminum bromide, the ratio is 1:3. Okay? If it is a different ratio, it's a different substance. It can be a different substance. But this would mean that this is a neutral compound. Okay. When we have the simplest formula, we call it empirical formula. Okay, we call it empirical formula. Now, so compounds are formed in accordance as well to the law of definite proportion. Okay, let's have an example of this. How do we use the charges in writing formula? So we have aluminum. Aluminum is found in group 3, therefore it has a positive 3 charge, positive 3, and then we have bromine, it's negative, okay? Negative 1. You have to make it neutral, okay? You can either do the mathematical calculation, make sure the summation of all the integers there is 0 to make it neutral. I will not discuss it anymore. I will use the crisscross or the shorthand way, the shortcut method of writing formula. We call it the crisscross method. All you need to do is to cross, okay? We cross it and then um, we cross it and then we drop the sign. Okay, we drop the sign. So again, we have positive 3, we cross it over to bromine and then negative 1. Then take note that when you write a formula, metal ion is always written first, or it's the cation that is written first. So we have aluminum 1, and then we have bromine 3, right? We don't write any more 1. Therefore, the formula is AlBr3. What are the ions used here? Positive 3 and negative 1. Next, I hope that's clear to you. I hope you can recall what you have learned in grade 9. Okay, here, sorry for the arrow, we have calcium, positive 2, phosphorus, 3 negative, right? It belongs to group 5A or group 15. Then we crisscross, metal ion is written first. Okay, so we have Ca, cross it to P Ca3 rather, P2. Okay, so that's writing chemical formula using the crisscross method. So it's very essential that you know the ionic charge. This is also to inspect if the formula written in a chemical equation is correct. Next, moving on, let's have some practice here. Let's have this example. Magnesium has positive 2 charge and sulfur has 2 negative. Refer to this table. We crisscross, okay, we have magnesium 2s2. This is not the empirical form or the empirical formula because empirical formula is the simplest formula, which means to say you need to simplify this because both subscripts can be divided by 2. Therefore, the final answer here is MgS. Okay, next, we have chlorine, calcium and bromine. Ca, 2 positive, and we have bromine, 1 negative. We crisscross again, we have CaBr2. Again, we write the cation first, followed by the anion. Did you get that? I hope that's clear. Next, another last three examples. Yeah, we have, um, I hope you're seeing that on the screen. Okay, now we have K positive 1, nitrogen 3 negative. Therefore, we have K3N. Okay. Now, you need to identify the charge. What if I'll give this to you? Al2O3. What are the ionic charges of the two elements present? Al, 3 positive, oxygen, 2 negative. Okay? For strontium phosphide, for strontium and phosphorus, Sr3P2. Why? Because strontium belongs to group 2, so you have positive 2. Phosphorus belongs to group 5, negative 1, negative 3 rather. Okay? So that's writing formula using binary in a binary compound, rather. Now, what about stock system? Stock system. I think this would be even more, it's even easier because you get to see what is being used. So when we say copper 2 chloride, copper 2, which means positive 2 is used here. So you have Cu positive 2, Cl negative 1. Therefore, the formula is CuCl2. We have Cu positive 1, Cl negative 1. The formula is Cl1. Did you get that? Just do the crisscross there. FeCl3. FeCl2, SnCl4, SnCl2. What if I have tin 4 oxide? So our tin symbol is Sn positive 4 and oxygen is 2 negative. We cross it, we will get Sn2O4. That is not the empirical formula. Therefore, the final answer is SnO2. Okay? I hope, again, you can recall, basing from this tutorial, you can recall that this was discussed to you when you were in grade 9. Next, what about polyatomic ions? You have there in your periodic table the list of polyatomic ions, or you may take a screenshot of this. Okay, so one thing to note in polyatomic ions, ammonium is the only polyatomic ion that is positive. One that is positive, having a positive charge. The rest here, as you can see on the screen, -1, -2, or -3. And another thing, binary polyatomic ion, it ends with IDE. These are the two polyatomic ions that ends with IDE, hydroxide and cyanide. And binary, I'm talking of binary, but this one is monoatomic, okay, ion, monoatomic, but considered polyatomic because there are two oxygen, peroxide. Okay, so how do we write the chemical formula, okay, of a compound involving polyatomic ions? Okay, so we have, for example, this one. You get to see this maybe in a chemical equation. So it is very essential that you give the correct formula or else you cannot balance the equation. Or if you may do so, everything is wrong. Wrong chemical formula, wrong balancing equation. So we have potassium nitrate, K positive, and O3 -1. We crisscross, we treat this, the polyatomic ion, as one. We treat it as one. So we have K Erase that first, change it to blue. So K, wait, K, then copy NO3. Do not ever change the formula of the polyatomic ion since you are asked to convert it, okay? So the correct formula of nitrate is NO3. We don't place parentheses because it's just one atom. You don't need to write a parenthesis. No. So this is the final answer. Next. Next. Let's have another example. Calcium phosphate. Calcium phosphate. We have Ca positive 2 and phosphate. Look at the list there. PO4 3 negative. We cross Ca3. We copy PO4. It's more than 1. Therefore, we place the parenthesis. Why? Because the 2 there is a multiplier for phosphate, which means 2, which means that 2 times 1, calcium phosphate has 2 atoms of phosphorus, and then 8 atoms of oxygen, 4 times 2. Okay, so again, it is wrong to write this way. CaPO4 2. Okay, that is not correct. Is that clear? I hope so. Next, move on to the next sample problem. We have ammonium sulfite. Ammonium sulfite. We have NH4, that's ammonium, positive 1, sulfite 2, negative. So we cross, we write the cation first, and it's more than 1, so we put parentheses 2, sulfite SO3. That's the correct formula. Okay, now what if we have the transition metal, copper 2 sulfate, Cu positive 2, sulfate SO4 negative 2. So we crisscross Cu 2 SO4 2. We simplify it into empirical formula. So we have CuSO4. That is copper 2 sulfate. Another thing that I want you to remember, that there are 2 compounds wherein we used it, the names are, we're using the common names of that, okay? So this is acceptable by the International Union of Pure and Applied Chemistry in writing names and formulas. So when we have water, H2O, you do not name it dihydrogen monoxide, no. Where if it is NH3, that is automatically named as ammonia. So water and NH3, water and NH3 for ammonia, okay? Now, I just would like to give a quick review also of molecular compounds. This is very easy, right? So we have here, how do we name and write formula of molecular compounds? We have N2O5. We use Greek prefixes. Greek prefixes. So we have nitrogen. It has 2 atoms, so we have 2 di, and that is dinitrogen. Then we have penta for 5, and that is pentaoxide. We take out the A because the next letter is a vowel. So that's pentoxide, dinitrogen pentoxide. Okay? Can you recall now this lesson in grade 9? Next, we have sulfur trioxide. Write the formula of sulfur trioxide. We have S, I, oh, sorry. We have, okay, we have SO3, trioxide. Okay, so how did we do that? How did we do that? How did we do that? Again, sulfur S, trioxide O3. So that's SO3. Next, what about this one? Name this. We do not say monocarbon. Mono is not used in the first element. So we just say carbon. Carbon, and there are 4 atoms of chlorine, therefore tetrachloride. Carbon tetrachloride. Okay, so I hope that's clear. You may use this to review you for formula writing. Again, which you need this for writing chemical equations. That's all. I hope this helps. So we go back to the learning target of the video, of this video tutorial. Can you now identify the charge of the ions? Can you write a chemical formula using the crisscross method? Okay, I hope you're able, or I was able to achieve that also, in how I delivered that in this video. That ends. Thank you.